So here is day 2 of 5.2, still dealing with right triangle trig. One new thing to think through that we talked about it a little bit in the SOHCAHTOA lesson is what a cofunction is. And the other component for today is going to be using the calculator, using it correctly. So take out a graphing calculator so you can do this along with me. I don't believe or know how if your phone can handle this back and forth because we are going to deal with radians and degrees. So first cofunctions, and then we'll get to the calculator. Little note there from the book, the cofunction of the complement. So complementary angles, remember, mean that they add to 90 degrees. And so the reason this works the way that it does, and we did talk about this a little bit in that last lesson. If I have this right triangle and I have my angle theta, this is the side that is adjacent to theta. This is the opposite side, and this will always be my hypotenuse. Now, in a right triangle, 90 degrees is taken care of by the right angle, and my other angles then have to always be complementary because a triangle always adds up to 180 degrees. So this has to be 90 minus theta. So the green one at the top and the blue one on the bottom left have to add to 90 because those two plus the right angle of 90 degrees will always be 180. Lots of throwback to whenever we first learned about right triangles in geometry or even before that. What happens though when we're dealing with this other angle is now the hypotenuse stays where it is. It's always across from the right angle, but what was adjacent now becomes opposite. So keep the color coding in line. So if I'm talking about the top angle, the bottom side now is the opposite side, and my what looks like the height of the triangle now is my adjacent side. So what would have been the sine of my blue theta, my opposite over hypotenuse, is now, if I take the sine of theta as opposite over hypotenuse, when I look at the cosine, or I'm sorry, when I look at the cosine of the other angle, which happens to be 90 minus theta, I'm talking about that same side. It just happens to be adjacent to that angle instead. So this opposite side here and this adjacent side here are actually the same side. And so that's the way the cofunction works. So you really just need to know which buddies are cofunctions. So sine and cosine, tangent and cotangent, and secant and cosecant will always pair up. So we really, if we have the left column of these notes, the right column is telling us the same exact thing. So the cofunction work that we need to do with degrees, I think it's way easier. But of course, radians we'll practice a bit. And that really, quite honestly, has to do more with fractions and finding common denominators than anything else. So for something like 31, if I have the sine of 7 degrees, if one angle is 7 degrees, my other angle in my right triangle has to be 90 minus 7 degrees. And so sine of 7 degrees and the cosine of 83 degrees, 90 minus 7, will have the same exact value. So, and we could check this in the calculator, which again, we'll get to in a little bit, but to double check yourself with these, if you have a calculator, the sine of 7 degrees will give you the same decimal point answer as the cosine of 83. It's that easy. 33, if it's the cosecant of 25 degrees, the cosecant and the secant are cofunctions. And so I have to take 90 minus 25 to figure out that other angle, which would be the secant of 55 degrees. And so same thing, once we see how to do these in the calculator, that's all that we have to check. Just subtract from 90. Where again it may be, and only maybe, gets a little bit tricky is when we have this in terms of pi. So it's the tangent of pi over 9 for number 35. And the cofunction will be the cotangent. 90 degrees is the same thing as pi over 2. And if you go back up here to the left, we have that little note up top. And so instead of 90 minus, we're going to do pi over 2 minus pi over 9. And so to leave this in terms of pi, to find a common denominator, the cotangent, even if you think of it as 1/2 and 1/9 instead of pi over 2 and pi over 9, the common denominator between 2 and 9 would be 18. So I actually have a 9 pi over 18 because 9 over 18 reduces to 1 over 2. And it would be 2 pi over 18 because again 2 over 18 would reduce to that 1 over 9, and so this is actually the cotangent of 7 pi divided by 18. So again, same idea, just playing around with the fractions instead, though when you see the problem written that way, your answer should be that way. It shouldn't be the cotangent of some crazy decimal point. So it's converting those fractions is all. Let's try one last one with the cofunction before we move on to calculator work. So the cosine of 2 pi over 5 is going to be the same as the sine of the complement. So pi over 2 minus 2 pi over 5. This time my common denominator would be 10 between 2 and 5. So 5 pi over 10 minus 4 pi over 10. 4 over 2, what was that? It made a rhombus. 4 over 10. It won't get rid of my rhombus. Get out of here. Skedaddle. 4 over 10 is the same thing as 2 over 5. And so this becomes the sine of just pi over 10. I wouldn't put the 1 in front of it. We wouldn't normally, but that's 5/10 minus 4/10. And the pi, again, they're like terms. We couldn't combine it if it wasn't a pi in both of them. But that's all that the cofunction does. So it's just that they are complementary angles. Sine is always cosine, cotangent, tangent, and then cosecant and secant. So those same notes as what we had up above. So calculator. 2 ways to use the calculator. I'm not going to do many of these because it really is just button pushing. But if you take a look, 39 to 44 are in degrees and 45 to 48 are in radians. We need to make sure that our calculator mode is correct. So if I go to my calculator and look at my mode, across the top, mine tells me that I'm working in radians. If I arrow down and over so that degrees is highlighted, then I now am working in degrees. So to find something like 39, the sine of 38, it is as simple as hitting sine 38. And so to 4 decimal places, it is 0.6157 is the way that it would round. Number 40, 41, 42, it's just pushing the button. All 3 of my trig functions are right there, sine, cosine, tangent. What maybe is tricky is something like 43. 43 says the cosecant of 17. And if you remember, that was the reciprocal of the sine. So sine and cosecant, cosine and secant, and then the tangent and cotangent are reciprocal. So not the same thing as the cofunctions that we were working with. So to find the cosecant of 17, you actually take 1 divided by the sine of 17. So if I could key in 1 divided by the sine of 17, I get 3.4203 to 4 decimal places. So just punching it in, it's that easy. Whenever I switch gears to radians, so something like 45 through 48, The same thing will happen when I look at my cotangent. I'll have to do 1 over the tangent, but the cosine of pi over 10 in degrees is not the same thing that it is in radians. So if I look at the cosine of pi over 10, knowing that my calculator is in degrees, which again I can see from up above, it gives me this answer. If I go to my mode and I change my calculator to radians, because pi over 10 is a radian measurement, and I again do the cosine of pi over 10, I end up with a different answer. So 0.9511 to 4 decimal points. So they were similar, but obviously not the same, and they're not always going to be quite so similar if you make that mistake. So something like 47, where we had the cotangent of pi over 12. This again, cotangent is the reciprocal of tangent, and so 1 over the tangent of pi over 12. And careful, use the fancy fraction if you need to, and watch for the parentheses, but 3.7321 to 4 decimal places for that one. So those couples should be super easy. It's just plugging the values in to figure out what the decimal point is. So really it's just checking the mode on the calculator. So the last one we actually have to solve. What if we don't know the side lengths? And we instead just have their ratio and we're trying to find the angle measure. So to solve, we can't just multiply, divide, subtract. That's not how we undo trig functions. So if I have the sine of theta equal to this decimal point, I have to take the inverse of both sides. So by taking the inverse, that will undo the sine and leave me with just theta. And so the sine inverse of 0.2974. So theta is equal to the sine inverse of 0.2974, which I just key into my calculator. So for all 8 of these, you have to pay attention to whether you're in degrees or radians, and then you just key it into your calculator. So I am in the wrong mode now, but just to show you again, second sine gives me the sine inverse. All I do is type in my 0.2974. .2974. And I get this crazy answer. If I switch my mode and I switch it to degrees instead, as it should be, and I take the sine inverse of 0.2974. 17 degrees. Very different answer. Very, very different answer. So all of these problems, it is just a lot of calculator work. And again, making sure that you first follow the directions. The exit ticket will have the same direction, so the number of decimal points, that sort of thing. But to make sure you are either in degrees or in radians. So if you need extra practice, work through these other problems. There are plenty of them, and they should be pretty quick, again, because it's a lot on the calculator. And then check with the notes. There is a PDF this time of all of these problems worked out. So from 31 through 48, all of those, and then this section from 55 to 62. And again, big ideas, the cofunctions, just knowing that those angles are complementary. And then when you're keying things into the calculator, remember, think of SOHCAHTOA and the reciprocal. So you might need the notes from the first day of 5.2 to keep track of those.